We're going to get into exactly how sharded clusters function, the various other pieces that can factor in here in terms of how well a sharded cluster can function. What we're going to focus on here is the connection buildup. And now I haven't gone out to shard n here, I've just left it at a 4 shard cluster, but in theory this can go out and out and out. Most people will deploy a MongoOS per application server and just have it running locally. So let's start drawing these out similar to the way we did for the replica set. So first of all, everything that applied in the replica set is going to apply here too. Your administrative connections between the shards, replica set heartbeats, replication threads, etc. You're going to have client connections between client and the MongoOS. This will be dictated by things like your connections per host. There's a new class of administrative connections that have been added to the mix, and that is the MongoOSs are going to be connecting to each of the primaries, secondaries, pinging those, making sure they're healthy. We'll add in a few examples of each just to show you how this stuff can quickly build up. And for every MongoOS, you're going to repeat this process and build up more and more of these administrative connections as you go on. Maybe you've got another piece of monitoring software that you're using to take a look at MongoDB. Maybe it's something else. But let's just say MMS and other out here. This will be kind of your outliers. And we'll put those in green. So you've got your client connections dictated by your driver options. They'll be opening up connections to the MongoOS, and the MongoOS is going to have to open up connections to service all of these. Now if you've got writes, a lot of them are going to be going to the primary. Everything's going to be going to the primary, so let's assume that is what's really going on here. If it's not, you'll see some connections, some of these blue connections hitting the secondaries as well, but as we saw when we were just looking at a replica set, it's the primary here that's going to probably be your bottleneck. And because this is now a sharded cluster, there will also be connections between the primaries. That's to do with balancing, things like that. So we're moving data around between the shards, there'll be connections there. They won't be there all the time, but I'm just going to draw them in there just so you're aware of them yourself. It's going to have a connection out. I'll draw this in red because it is essentially an administrative type function. It's going to have at least one connection out to the config servers and probably multiple of these depending on what it's doing. Every time there's a chunk moved between the two, it'll have to connect to the config servers and update it. It'll have to connect to the config servers and get updates from there as well. And of course all of the MongoOSs are going to be talking to the config servers. Not a huge factor here, but just worth noting that that's going to be happening as well. What this illustrates is that, once again, this here, this primary, is going to be your focal point. Let's say we add in one more set of blue connections here. You can see this primary is most definitely our focal point for the number of connections. As you add more and more clients, drivers, applications, whatever it is that you're using to actually connect to the MongoOS, the number of connections to the primary is going to go up accordingly. And this is being specified by you, assuming you're actually maxing out things, in your driver options, connections per host, how busy they all are. And you can imagine that 100 MongoOSs here, and each of them is servicing just 20 connections. And all those 20 connections are hitting the primary. Then it's 20 by 100. You've already got 2,000 connections. And that's not a very high number of requests for a MongoOS to be dealing with. So 2,000 doesn't sound like too bad. It sounds like we'd be able to handle that. We've got some overhead here as well. So you'd probably end up with a primary with maybe a maximum of sort of 2,100 connections. That doesn't sound too bad. It's 2 gigs of memory. It's not trivial. But certainly you can see how this is going to multiply and escalate quickly. Let's say that our N number here is instead 150. And let's say that the number of concurrent requests that we're actually going to deal with is 100. Now we've got 15,000. That's a much more significant number. For one thing, there's going to be some overhead here as well. So let's just say 15,500. You're up to 15.5 gigs of memory in usage on that primary. You're also noticing that that's quite a high number. You're going to have a lot of connections, a lot of open file descriptors. Are you going to run into ulimit problems? And you know that your cap is 20,000. At 15.5 out of 20,000, that's greater than 75% utilized. Anytime you see anything go over 75-80% utilized, it's time to worry. In computer science in general, that's true. If the network gets more than 80% saturated, time to worry. If any sort of limited resource, in this case the maximum number of connections, we've now breached the 75% rate without being terribly adventurous in the number of concurrent connections that we're using. The fact that this multiplies out can cause this to escalate quickly. So what is our actual formula here? How would we limit the impact? If you run out of connections here on this primary, what is going to happen? You're going to start going down a path whereby the behavior of this primary is now unpredictable. If it's full, if it can no longer open a new connection, you might get a socket exception. You've run out of file descriptors completely. What if it needs another file descriptor to access a data file? What if you've allocated a new data file and it can't get that? What's going to happen in that scenario? What's actually going to happen in that scenario is there's a certain amount reserved for file system access versus connections, but you can see where this is going. If you're starting to run out of that resource, you're getting in a state whereby you can't predict the behavior of your shard. You can't predict the behavior of your primary. Maybe it will get into such a state that it can no longer answer the heartbeats from the other members of the replica set, in which case it might be decided that this primary is no longer healthy, time to elect a new one. Now you've promoted something else to primary and that's going to get flooded with connections. How's this going to manifest to your clients up here? Socket exceptions, timeouts, slowness, all sorts of other things that could potentially manifest here, and it's not something that you want. You don't want to get into the situation whereby your cluster could crash, your primary could fail, you could get various random and undetermined consequences because you've essentially run out of a vital resource. So how do we stop this from happening? Well, there is a parameter on MongoS that allows you to limit the number of connections that a MongoS will actually do. So it's actually called --max cons, and you set it to an integer, so you would set it to say 100. And what that'll do is it'll stop allowing connections to come through this MongoS once it reaches 100. The fact that you can limit the connections up here at this layer can insulate your actual shards, your actual replica sets from getting into this undetermined state. Once the MongoS starts to bump into this limit, you've got a predictable behavior. You'll literally start running into connection timeouts based on your driver options, of course, because it can't open another connection to service the request you're sending it. You then have a sort of a known consequence of maxing out your resources here. So how do you come up with that formula?